Okay, 9.2 is test about a population proportion. What do you think 9.3 is going to be about? Okay, test about a population mean. So you kind of have seen the pattern since chapter 7 that section 2 is always proportion, section 3 is always mean. And that's the way it is for this testing as well. And so we just do proportion. And so there's only kind of a couple of difference between when we're testing with proportions versus when we're testing with means. So it kind of makes the next section even easier. The main difference between when we're dealing with proportions versus means, like when we were doing confidence intervals or when we were doing the previous chapter 7, was that with proportions, to find the standard deviation, we do the square root of p times 1 minus p over n. Does that sound familiar? Yes, I hope so. Okay. How do we find the standard deviation when we're dealing with means? It's just standard deviation divided by square root of n, right? Okay, I noticed that on your last test, a lot of people on the free response, the one that dealt with the proportion, they kind of just left that one blank because they forgot how to find the standard deviation, and so you couldn't carry out the rest of the confidence interval. Don't do that. Look at your formula sheet. It's on there. All you need is the proportion and the sample size, and you can find the whole standard deviation, okay? There's one other big difference between testing with a proportion versus testing with means, and that's within your conditions. When you write up, they both have to have random. They both have to have the 10% rule that says the sample has to be less than or equal to 1/10 of the population size. But what does proportion need for conditions? For proportions, we need CLT? No. Proportions, we need large counts, okay? Proportions, we need large counts. That's the NP is greater than or equal to 10, and the N times 1 minus P is greater than or equal to 10. For means, we need CLT. Please quit calling that large count. A lot of people are writing large count and it's greater than or equal to 30. No, that's CLT, which we call the large sample, okay? So your sample size has to be 30 or more, and if it's not, then we graph the distribution and we say there's no outliers and no strong skewness. A lot of people on the last test, they were, you didn't even have to graph it because it gave you a graph within the scenario, but they would just say, oh, according to the graph, we can assume normalcy. No, don't go there. You say, here's the distribution, here's what it looks like. There's no outliers, there's no strong skewness. Don't call it normal. It's not normal. We can't assume normal. We don't even have a sample size of 30. You can't assume normal, okay? And we never want to say that anyway. We want to say approximately normal if we want to go there. So be careful of that. So anyway, we're just dealing with proportions today, so we're not dealing with CLTs or 30 or any of that good stuff, okay? So since we're going to state and check random 10% in large counts, we're going to perform a significance test, interpret the power of a test and describe what factors affect the power of a test, and then describe the relationship among the probability of a type 1 error, which remember is your alpha. That's your significance level. If our alpha is 0.05, then the probability of getting a type 1 error is 0.05, 5%. Okay, that's the same thing. The probability of a type 2 error, and then the power of a test. So recall our basketball player who claimed to be an 80% free throw shooter. In an SRS of 50 free throws, he made 32. His sample proportion of made shots was 32 out of 50, which is 0.64, 64%. Is much lower than he claims. Does it provide convincing evidence against his claim? So we're going to do an entire test with this data alone. This right here, I put a blank slide for us, so ignore that. And we're going to write up how we would write up his test. So we're going to do the 4-step process. We're going to do state, plan, do, conclude. Excuse me? If it says perform a significance test, yes, you have to do state, plan, do, conclude. Do you have to write state, plan, do, conclude? No, but you have to have all the elements that are in. So we might as well have it organized to make sure that we have all our elements. But if it asks you to perform a significance test, and you'll see on your practice worksheet, there's going to kind of be a hint there that they want that, because all it says is perform a significance test, and then it gives you like the whole sheet of paper blank. That's not a typo. They want you to do the whole process. Okay? So for the state of a significance test, we have to define the variable. We have to do the null hypothesis, the alternative hypothesis, and set the significance level. They didn't set the significance level for us. Okay, so what variable do we need to define? What parameter are we going to use? P. P is equal to the proportion. It was free throws, but yeah, free throws made, would that be good enough? The null hypothesis is the guy's claim. He claims to be an 80% shooter, so I'm going to go with P equals 0.8. The alternative, it didn't really say it on this previous slide, but when we did 9.1, it talked about that we thought he was exaggerating. So what do we think alternatively is happening? We think he's shooting less than 80%. So we're going to say P is less than 0.8. The last thing in our state that we need to do is we need to define a significance level. What am I talking about? Alpha. Okay, so if they don't give you an alpha, what do you assign it to be? So we're going to say alpha is 0.05. That needs to be in the state. So we've set up our null hypothesis, we've set up our alternative hypothesis, we've defined the parameter, and we've set our significance level. Now we plan, and the plan has 4 parts because we list our conditions under the plan. So that alone is 3 parts. What's the other part? A lot of people miss this one. What's that? Which test we're doing. Okay? A lot of people on the last test forgot to say, I'm doing a 1 proportion Z interval, or I'm doing a T interval. You have to name what you're doing. What's the plan? What are you trying to do? I'm trying to do a 1 proportion Z test. It's a significance test. It's not an interval this time. Okay? And in order to do a 1 proportion Z test, I have to have random. I have to have 10%. I have to have large counts. Writing these words and putting a check mark next to them is not enough. And I saw a lot of people do that on the test. It's not enough, okay? We can get away with saying random, SRS stated. It did say on the previous slide that they did an SRS. So we can say SRS stated. Unfortunately, for 10%, we have to assume, but we have to explain that. So for 10%, we're going to say, assume 50 is less than 1/10 of all free throws he will ever attempt, something like that. Or you could say, we'll assume he's going to attempt more than 500 free throws in his life. Like 50 would be 1/10 of 500, right? So we'll assume that he's going to attempt 500 or more free throws in his life. So 50 can be less than or equal to that. But you have to say some type of assumption about it that makes it true. And then large counts. A lot of you didn't even stop there. You went NP greater than or equal to 10. N1 minus P greater than or equal to 10, and you stopped there, and I counted it wrong on your test. You have to show the work. Okay, you can't just say what large counts is. You actually have to plug the numbers we have into it. So our sample size is 50. The proportion that he makes is 0.8. Okay, 50 times 0.8 is at 40. So 40 is greater than or equal to 10. So that's good. And then we're going to do 50 times 0.2. Okay, so that's 10 is greater than or equal to 10. We really lucked out there because of that equal to, but greater than or equal to. So it does meet it as well. So we've named the test we're going to do, and we've listed all of the conditions. There's always going to be 3 conditions. Random, 10% are on both proportions and means, and you do large counts for proportions. You do CLT for means. Are we okay with all this? Yes, ma'am. We want to use the population proportion, the hypothesized claim. Good question. The only place that we're actually going to use the sample proportion is finding the z-score. We'll use it as the observed score. Yes, ma'am. For means. So when we do 9.3, it's going to be testing a claim on means. Then we'll do CLT. Large count for proportion, CLT for means. Okay, so for the do part of our process, we need to find a z-score. And then we need to find out what is the probability of being below that z-score. I'm going to walk you through how you would do it by hand, and then I'm going to show you like a super quick way to just do it on the calculator. But bear with me as we walk it, go through it by hand first. So the first thing you would do is find the z-score. Remember that a z-score is observation minus mean over standard deviation. So what is his observed score? 0.64. He got 32 out of 50, so he made 64% of his free throws. What's the mean? What's the hypothesized proportion? The 0.8. What's the standard deviation? That's where we all go. It's the big square root ugliness, right? So it's square root of p times 1 minus p over n. Are we using 0.8 or are we using 0.64? We're using the population data, so we're using 0.64. P, not p hat, okay? So we're going to do 0.8 times 1 minus 0.8 divided by 50 because our sample size is 50. Okay, so this again is helping us find the z-score. I'm going to just do it all at once on the calculator. Let the calculator handle it for me. Okay, so that gives me a z-score of negative 2.828. I need the probability less than that z-score. Sometimes you're going to need the probability of being greater than that z-score. Sometimes you're going to need the probability of being either less than or greater than. How do I know which one to do? Why is it less than? Because our alternative hypothesis is less than. Do y'all see it? Okay. So if you imagine, y'all don't have to draw this in your workup or anything like that. You've got your mean in the middle. You've got -1, -2, -3. We have a z-score down here at -2.82, almost at -3. So I'm wanting the area less than that. So I'm wanting that area to the left of it. So you can look on your Z table if you want to find the area on there, or you can use normal CDF on your calculator. You know what I'm going to do? I'm going to use my calculator, okay? So I'm going to do second vars, number 2. I'm going below the z-score. So my lower bound is going to be -infinity. So I'm going to just do a -10 to represent -infinity. I'm going to do a z-score of -2.828. This probability that I'm finding, guys, under the area to the left of that z-score, that is my p-value. The p-value is the probability of being at that observed score or lower. Okay, so there's a 0.0023. Not even 1% of the time should he be shooting 64% if he's truly an 80% shooter. Okay, so it's a very low probability. So in our do, you can either say look up on table, or you can say normal CDF, but you need to tell them within your do part of your write-up what you're doing to get your p-value. So I would say normal CDF of -10 to -2.82. Sorry, write that again correctly. -2.828, and then 0 for the mean, 1 for the standard deviation, gave me a p-value equal to what? 0.002 something? 0.023, thank you. So then from there, we're ready to conclude. What would we conclude? That's where you interpret, but we need to back up a little bit and compare it to our alpha first. So how does this p-value compare to our alpha value? 0.0023 is less than 0.05, so p is less than alpha, so what do? You reject the null. You need to say that in your conclusion, but it's not enough. You need to say reject, null. Then you write the sentence of what that really means. Okay? So it means that we have convincing evidence that it's not true that he's an 80% shooter. We have convincing evidence that the alternative is true, that he actually shoots less than 80% of his free throws. I'm not going to take the time to write that whole sentence, but that's the type of conclusion you would have to write. You need to write your statistics conclusion that we reject the null because the p is lower than the alpha, but then you need to go on and say what that means in the context of the problem. The next 10 slides do all that. Do you feel pretty comfortable with what I just did? Everybody okay? So I'm going to run through the next slides, okay? So here's where they're reminding you about all of the conditions. We feel comfortable with that. Proportions do large counts. Means do CLT. So when you have proportions or percentages, you should not be putting 30 on there at all. Okay, large counts has to be n p is greater than or equal to 10 and n times 1 minus p greater than or equal to 10. Okay, they go over how to find, they go over how to find the standard deviation with the proportion. We did all that on the calculator and how it's set up and where our 0.64 would fall, because it is negative 2.82 standard deviations below there, so it's almost at that negative 3 standard deviation. So they're just telling you how to carry out the test. So finding the test statistic, you're going to do your observation minus your mean over standard deviation. Any idea why they're calling it test statistic instead of just calling it z-score? You think we'll be doing z-scores next section? Guess what we'll be doing? What's that? T. Yeah, we'll be back to doing T's because remember Z went with proportion in chapter 8 and T usually went with means in chapter 8. So yeah, that's why they're calling it test statistic, is because now it's interchangeable. We could be doing Z's or we could be doing T's. Today, all you have to focus on is Z's. You know what? I forgot the best part when we worked that whole problem out. Guess what I forgot to show you how to do? Legal cheating by doing the whole thing on the calculator instead of working anything out by hand. We like that way better, don't we? So let's learn to do that really quick. Okay, so in chapter 8, I showed you how to find confidence intervals on your calculator. Where did we go to do confidence intervals on our calculator? Stat over to test. And if we had proportions, we did alpha A. And if we had means, we did number 8. Is that right? Is that right? So alpha A was one prop Z interval, and then number 8 was just T interval. Well, now we're not doing intervals, now we're doing tests. So guess which one of those is the correct one for the basketball problem? Number 5, very good. It's a one prop Z test. It's not an interval, it's a test. So we're gonna do number 5. Guess what the P naught is supposed to be? 0.8, very good. It's the hypothesized population proportion. So it's gonna be the number you're using within your hypotheses. So 0.8 goes there. Guess what goes in X? 32. Very good. 32 is how many he successfully made. So what do you think N is? 50. The only other part you have to put in is which way your alternative hypothesis is going to go. Is it not equal to, is it less than, or is it greater than? Our alternative, what was it? It was less than. So we select that and go down to calculate. It's that simple. Isn't that awesome? Okay, notice they do give you your z-score. So show that in the do part. Even if you're going to legally cheat and use your calculator for the whole thing, I say it's legal cheating because there's nothing wrong with doing it on your calculator, but you're going to have to, you know, give some information for the AP grader of what you're doing. So you're going to put the test that you're doing on the calculator. You're going to fill in the P naught, the X, the N, show them which way you're making your symbol go, and then also go further and tell them what z-score you got. Tell them what p-value you got. But do you notice that it is the same as what we got when we worked it out by hand? Y'all see that? the same information. Okay, what's this P thingy down there that's 0.64? What is that? That's P hat. It's just the sample proportion. If you did 32 out of 50, wouldn't you get 0.64? So they've just calculated the sample proportion for you, no big deal. So that's how you would do it on the calculator. Okay, so moving forward, they did the z-score by hand. I think y'all got that. They're showing where it's at on the curve. They're showing that they looked at the table to find the p-value, got the same thing we got. Why are they saying there's a 2 in 1,000 chance that he's going to shoot 64%? Yeah, 0.002, if you think about what that like actually say it, isn't that 2,000? 0.002, that would be 2,000ths, right? So 2 out of 1,000 chance that he's going to do that. So they're reminding us to do the state plan do conclude. When we're doing, we need to show the test statistic, we need to show the p-value. So if you're using the calculator, then on the do part of it, not only put on your do part, like write down on your do part what you're inputting, also write the output when you get the screen that after you've calculated it. So they do want to see what your test statistic and your p-value is. And then notice in the conclusion, they want us to write our the decision about the hypothesis in the context of the problem. It's not enough just to say reject or fail to reject. What does that actually mean? You have to go further than that. Okay. Looking at the different alternative hypotheses here at the bottom, you could have, if it's a greater than, then you're finding the area in the right side tail. In the middle here, if it's less than, like the one we just did, then you're actually finding the area in the left-hand side of the tail. But if you have a not equal to, notice you're finding the area below the negative z-score and above the positive z-score. So if we were just trying to find the probability that he didn't shoot 0.8, like we didn't think he shot higher, we didn't think he shot lower, we just wanted not equal to 0.8, then we would have had to take the area below that z-score and basically double it. Because since it's symmetric, wouldn't it be the same on the right side as well? So we would just take whatever p-value we got and double it. Your calculator, if you use the testing function, it will double it automatically for you if that last thing you choose, if you choose the not equal to symbol, it'll just double it for you automatically so you don't have to worry about that. Okay, so that's the two-sided thing I was just talking about where it's on both sides, both tails. Okay, this is going to be somewhat helpful in your practice worksheet. I think the very last question on your practice worksheet has to deal with going back to confidence intervals. The result of a significance test is basically a decision to reject or fail to reject the null. When we reject the null, we're left wondering what the actual proportion P might be. A confidence interval might shed some light on this issue. How do you say that? Taeyeon? We're calling him Taeyeon? Okay. Taeyeon found that 90 of an SRS of 150 students said that they had never smoked a cigarette. The number of successes and the number of failures in the sample are 90 and 60 respectively. So we can proceed with calculations. So they're reminding us of how you would do a 95% confidence interval. I do notice that my critical value is 1.96. That comes from the 95% confidence level. They're doing 60% because that's how much, what proportion of students they think smoke or whatever. That's the population proportion. Or actually, I guess it would be the sample proportion. Is 90 over 150 actually 60%? They're going to make me calculate it. It's not. So where are they getting 60% from? Did I miss that piece? Okay, so that's where the 60% came from. It's the 90 out of the 150. So anyway, then they're doing the P times the 1 minus P over the N, and they're calculating, and they found the confidence interval. So if a school, let's say, is claiming that less than 50% of students smoke, so they're like, hey, less than 50% of our students smoke, and I guess it's backwards. If they're saying greater than 50% of our students smoke, because isn't the 90 the ones that don't smoke? 90 out of 150 don't smoke is what the scenario said. So anyway, if they're claiming 50% going in the direction, it's not in the interval, is it? Y'all get me? So we would reject the null if they were claiming 50% or less, because it's not in the interval. So there is going to be a problem like that on your practice worksheet, which means there's going to be one on your daily check, where you will have to check the claimed value and see if it's in the interval. And it can lead you to reject or fail to reject. So if it's not in the interval, you're going to reject the null, but if it is in the interval, then you say you failed to reject the null. Okay? I'm going to try to get to the power stuff. So here we go. Type 2 error in the power of a test. A significance test makes a type 2 error when you fail to reject, right? Type 2 is when you failed to reject, but the null was false. So you said, hey, we think this is true, but no, it really wasn't true. There are many values of the parameter that make the alternative hypothesis true, so we concentrate on one value. The probability of making a type 2 error depends on several factors. Thank goodness we don't have to find it, okay? But the probability of making type 2 depends on several factors, including the actual value of the parameter. A high probability of type 2 error for a specific alternative parameter value means that the test is not sensitive enough to usually detect that alternative. The power of a test against a specific alternative is the probability that the test will reject the null hypothesis at a chosen significance level, alpha, when the specified alternative value of the parameter is true. So they go through this whole scenario about potato chips, having a null hypothesis of 8%, and then you want it to be greater than 8%. They don't really even tell us what exactly they're doing, but they're trying to count what percentage of the potatoes are good from a shipment. So they're trying to do, they say you have like 8% blemished potatoes or whatever. So anyway, they don't really give us enough detail to understand the scenarios. I'm just going to keep on moving. Keep going, because we didn't do the potato problem. I don't know where they're getting this from. So the significance level of the test is the probability of reaching the wrong conclusion when the null hypothesis is true. The power of a test to detect a specific alternative is the probability of reaching the right conclusion when the alternative is true. We can just as easily describe the test by giving the probability of making a type 2 error, sometimes called beta. So the power of a test against any alternative is 1 minus the probability of a type 2 error for that alternative. That is, power is equal to 1 minus beta. So that's all the stuff we should have done. I at least want to do the very first problem on the practice worksheet with you. And then I'll do a recording of the rest of the worksheet worked out because we won't have a chance to finish the entire thing. But at least let's try number 1 together. Okay, so we're on practice 9.2. And it's just doing a test again, just like we did the basketball problem, but we have to do the 4-step process because it says we are doing a test of significance. I think part B is actually the conclusion though, isn't it? And the context of this problem. So kind of part B is the conclusion, but they gave us a lot of room for part A. I think they expected us to do the state plan and do, because they gave us so much room and they're telling us to do a test of significance. So you got to do the whole thing, okay? 11% of the products produced by an industrial process over the past several months have failed to conform to specifications. The company modifies the process in an attempt to reduce the rate of nonconformities. In a random sample of 300 items from a trial run, the modified process produces 16 nonconforming items. Do these results provide convincing evidence that the modification is effective? Support your conclusion with a test of significance. So for the state, we need to define our parameter. P is equal to the proportion, of nonconforming products, but we need to say like after they've done their new process though, right? Because they're modifying the process and we want to see if it got better or not. After modified process, I think would be enough.
Should we do a proportion of all?
that would be even better, because we want to tell the graders that we know that when we're defining a population parameter, it is a population, and saying all lets them know, hey, this person knows what they're talking about. We would not want to use numbers like 16 and 300. That would not be good, because those are sample values, and we don't want to put that within a parameter, okay? So that's good. Put all in there to show them you know you're talking about a population. So it's the proportion of all non-conforming products after they've modified the process. Good enough. What's the null hypothesis? Okay, 0.11, and it's hidden. Everybody see that first word is 11%? It's hidden up there in words, so you're like, where did the 11 come from? Well, it's the very first thing they talk about. That is the population proportion right now. It's 11% before they modify the process. So alternatively, why would you think it's less than? Okay, keyword is reduce. They're attempting to reduce the non-conforming. Okay, so it is less than. Did we do enough for state? Very good. Alpha, right? We've got to identify the alpha level, and so we want to just set alpha equals 0.05. Now we're good for state. Now we do the long part, the plan. Okay, our plan is to hopefully do a 1 proportion z-test. Do not call it an interval. If you call it an interval, it's wrong. Okay, our hope is we can do a 1 proportion z-test. What allows us to do that? We want random. We want 10%. We want large counts. We don't want large sample. Large sample is if we're trying to do a 1 proportion, if we're doing means. So we're wanting to do a t-test. Okay, but we're not doing means, we're doing proportions. So we want large counts. Random, does it state it somewhere? Yes. Okay, random sample is stated. I should have written random, sorry. Random sample is stated. And again, we have to assume on the 10%. What are we assuming? So we're assumed. You could say we assume they make more than 3,000 products, or we could say we assume that 300 is less than or equal to 1/10 of all the products they make. You can do it either way. Assume 300 is less than 10% of all products made. Okay. And then large count, we have to do NP greater than or equal to 10, and N1 minus P greater than or equal to 10. So N is how many? 300. P is 0.11, right? Okay, so then on the other side of it, we would be doing 300 times 0.89. Because if 11 is our success, then 89% is our failure. Okay, what's 300 times 0.11? Is it 33? So yes, that one works out. What's 300 times 0.89? So 267 works out as well. Did I get it all? Bless you. I named my test, random, 10%, and large count. So I've done everything I need to do on the plan. Now I need to do the do. I personally would use the calculator and then just write everything down from the calculator. So I would go stat over to test, number 5 for the 1 prop z test. 1 prop z test. Absolutely. You can find the z-score and then do the normal CDF or look it up on the table. Absolutely. The 16 out of 300 is your observed score. Yep. 0.11 is your population proportion. Okay, so we would have a P naught of 0.11. We would have an X of 16. We would have an N of 300. And then our Direction, does it say P naught, or what does it say when you're picking which way the symbol goes? Prop? Uh-oh, it erased too much for me. Try again. So it says P naught is 0.11. It says X is 16. N is 300. Prop, and we would put less than. Does it say less than P naught is what it says? So you would need to show all that. Then you would need to calculate it. I didn't even change it. I was just going to go on. 0.11, 16, 300, less than, and calculate it. And then give them the z-score under your do as well. So we have a negative 3.14. And we have a p-value of what? Everybody okay with writing down p-value 8.5? No. How big can your p-value be? 1. So if you get something bigger than 1, then make sure you look at the end and it's actually 0.0085. 30, sorry, and then 85. Okay? You guys have a good day. Sorry we didn't get to finish. I will finish recording a whole practice worksheet for you and post that for you. Have a good day.